Okay, so we had a couple questions here. One was about the SFPs and the QSFPs. Are these just adapters or do they do more? The only thing that they're doing is doing a layer 1 conversion of the protocol as it goes out the physical port onto the physical wire. Now, the reason that most network equipment uses that nowadays is that when you originally bought a switch, you had to buy the physical module to say, do I want to connect with a multi-mode fiber or do I want to connect as a single mode fiber? So like if you look at the old like Catalyst 2900 series switches or the old Catalyst 3500 XLs, you would buy the switch as to say, I want a single mode uplink or I want a multi-mode uplink. So they had to make physically 2 different versions of the switch. Okay, the SFP simplifies that by decoupling the layer 1 properties of the link from the layer 2 and the upper levels. So we decide, do we want to use copper? Do we want to use multi-mode? Do we want to use single mode? By choosing what particular SFP that we're going to plug into the port. Now, the one thing that you do have to be aware of, though, is that the type of SFP and the cables that you use are very specific to the specific platform that you are working with. So there is, let me see if I still have the link. There is this page here that is the Cisco transceiver module capability or compatibility matrix, which basically shows you what particular SFPs the individual port is going to support. Like if we take a look at and I'm not sure, this might not be the right, yes it is. Okay, so let's say for a Nexus, and we look at the Nexus, let's say 5Ks. Okay, and we look at our specific model, which would be 5548 UP, or the new ones like the 5600s. It says you can run GLCT, which is a copper GBIC. Okay, so it's like a, it's an SFP, but you plug in RJ45 on the other end. You could run GLC SXMM, which I want to say that is the short range SFP. And it also shows I believe it also shows what the distance limitations are for them. Okay, like this one here, let me see, what's the part number for the TwinX? It is, and you can see this is on a per module basis. So when you're looking at the Nexus 7K, you would need to look at your specific part number, and then it tells you exactly which type of cables are supported. I'm not 100% sure offhand which one is the TwinX, but basically the layer 1 capabilities at the port, that's all that it does. So when you are looking at which one you're going to use, mainly it's based on the distance limitation. So if it's a short run, you normally would want to use TwinX because of the cost of TwinX. It's lower than the multi-mode, which is going to be for the mid-range runs. Then if it's a very long distance one, you would run the single mode fiber, but the single mode fiber is much more expensive than the long range ones. Or excuse me, the short range ones. And I'm trying to find the specific part number for. I think this is not the document I was looking for. Let me see. What is this one? SFP modules for Gigabit Ethernet applications. And I'm trying to see which is the long distance one. It should be that one, the single mode, right? So if you look at these from just like a pricing point of view, and I'm assuming that one might be 1 gig. Yeah, these are 1 gig. I'm looking at the wrong page. We need the 10 gig Cisco SFP page. So let's say SFP 10 gig LR. So you can see some of these are like 500 a piece. And that actually seems kind of cheap for that. There's the other longer range ones, the extended range. And these are you could see like 3,000 a piece. So as you can imagine, and of course you can't have just one because you have to plug the cable into something on the other end. So once you start to add up the cost of the SFPs, it can very quickly overrun the cost of the physical platform. So that's why you would want to plan this out from a physical placement point of view. You ideally run most of your runs in rack to the top of rack, and then you would minimize the number of runs that you need to do between the cages, because depending on how physically long these runs need to be in the data center, these SFPs quickly start to add up, as you can see. And somebody said the ZRs are the most expensive. Those are the, but anyways, you could see that yeah, someone had mentioned when you purchased them about 9 months back, they were $3,000 for new. So figure for each cable, that's $6,000 per cable, not even including the physical fiber run. And if the switch is costing you, $20,000, $30,000, you don't need that many ports in order to, to go beyond that particular price. But from a functionality point of view, and I think this was the page I was looking for, the 10 gig e-transceiver model compatibility matrix. So you need to make sure that when you actually purchase your SFPs, that it's listed as officially supported for that individual line card. Because what will happen is that if it doesn't list it explicitly here, a lot of times, even though it's a Cisco module, or even though if it is a Cisco module, sometimes the platform will not recognize it. And there's some workarounds for that you can do, but you sometimes can end up getting layer 1 errors on the port, and it's something that's very, very difficult to track down if the problem in your network is the actual SFP itself. Okay, but these part numbers here, the SFP H10GB-CU1M, this would be the 1 meter twinax, which you could see that these are like, $18. So $18 versus $3,000 per link, you ideally want to run as many of the twinax runs in rack as possible. Okay, then as someone else had mentioned, between the 2Ks and the 5Ks, there's also another variation of this, which is called the FET cables. These are specifically for the fabric extenders, and they let you go a little bit longer than the twinax ones, but they're cheaper than the regular fiber SFPs. Okay, so kind of a long-winded answer, but no, there's no difference between the SFPs. It's just a layer 1 capability.